I wish I could visit the Arctic Ocean. Icy expanses reminiscent of another universe. The trip is definitely too expensive for my limited funds, but I can't do it any longer since the Arctic ice could gone in 7 years. This is what a recent study cautions about in Nature, and it comes as a surprise because the latest IPCC report predicted it would happen over a long period of time. The previous IPCC study even projected it would happen as early as 2080. You could believe that the disappearance of Arctic ice is anecdotal, but it could signify that we are losing the war against climate change. So what makes this study unique? What are the consequences of an ice-free Arctic? What does this mean for the climate fight? Come find out with us. (2030). This year could be the first with a completely ice-free September in the Arctic. Why September? Because it is the end of summer, the hemisphere has accumulated the most heat and the polar ice sheets have shrunk to their smallest size. To be fair, the study I'm presenting today provides a time frame rather than a date. In the best-case scenario, this would occur around 2050, but in the worst-case situation, it may occur by 2030. It is no news that the ice sheets have been melting for years. Since 1968, scientists have been monitoring the ice caps and alerting us about their melting. The issue is that they melt quicker than any available simulation. So, what makes this study unique, you could ask? It begins by calculating the true sea ice area using satellite pictures from 1979 to 2019. This significantly reduces the observed uncertainty in earlier investigations. Previously, scientists used satellite photos, but they divided them into grid cells using a 15% threshold to determine if a grid cell included ice or not. Second, this study replicates the impact of greenhouse gases on sea ice throughout the year. This explains the gradual melting when the majority of previous research focused solely on September. With these data, scientists may now compare the projections to the IPCC's SSP, Shared Socioeconomic Pathways, scenarios. And, regardless of how much we reduce our emissions, the Arctic summer ice sheets may disappear between 2030 and 2050. Now, I realize some of you are probably asking why melting ice caps would be terrible news for climate change. Well, it's a reasonable and relevant question, and to explain this, we must first grasp another concept in climatology known as tipping points. Nature is made up of numerous balanced ecosystems. Some of these balances are global in nature, while others are regional in nature. These ecosystems are made up of all living species that have adapted to their surroundings. Any drastic changes in these balances necessitate adaptation, whether to survive rising temperatures, changes in food supplies, or other disruptions. Earth and life have existed for billions of years. Throughout this time, these changes compelled adaptation via DNA mutations or natural evolution. A change in temperature does not imply the Earth will perish. Ecosystems will discover new balances, whether they are beneficial to existing living creatures or not. However, if the changes are too harsh or abrupt, large extinctions will occur, with only the fittest surviving. Obviously, humans vary from other living species. We are the only known creature capable of voluntarily shaping its environment. And the size of our imprint is enormous, whether it is to serve beliefs or to satisfy greed, satisfaction, and energy wants. But the question is whether we will be able to modify ecosystems based on what is happening. The IPCC identified a tipping point in its 2021 report as a critical threshold beyond which a system reorganizes rapidly and/or irreversibly. Even if this term refers to a sudden transformation, it should not be interpreted as something that occurs overnight. It is a significant adjustment that will take years to complete. And often these changes occur in a covert manner long before we notice or understand them. So far, the scientists have found a number of tipping points. You've probably heard about the withering low-latitude coral reefs and the melting mountain glaciers. These are the local ones. However, there is another type of tipping element, the core global ones, which have an effect on the entire globe. Antarctica and Greenland are covered with ice sheets that are kilometers thick. The experts anticipate that their melting will cause a 1.5 degrees increase in Greenland and, depending on the area, a 1.5 to 7.5 degrees increase in Antarctica. This melting will replenish the ocean with millions of tons of fresh water, rising by more than 60 meters in total, triggering enormous extinctions in marine life and, more significantly, a temperature runaway by interfering with plankton CO2 absorption. Ocean currents are another key global tipping point. Convection between cold and warm water, for example, warms the American and European coasts while tempering low latitude once in a while in the Atlantic Meridional Overturning Circulation, or AMOC. The scientists predict a 4 degrees increase as the tipping point. As fresh water remains atop the salty one, it may delay or stop these currents. And, by the way, there are signs that the AMOC has begun to deteriorate. Another tipping point is equatorial rainforests, which are one of the most important carbon sinks on the planet. It is predicted to reach a point of no return around 3.5 degrees rise, assuming that deforestation does not destroy it first. And there is one more significant worldwide tipping point that we shall discuss later. Summer sea ice in the Arctic is not a tipping point. However, the winter one is. Its tipping point was calculated to be around 6.3 degrees. According to this study, even if we substantially reduce our emissions to 1.8 degrees Celsius, the Arctic sea ice would begin to disappear shortly. It was also interesting to note that the 1.5 degrees scenario is no longer mentioned anywhere in the study. Without making any assumptions, temperatures have already reached 1.15 degrees, and several scientists have already chastised the community for stating the obvious. In any case, if these tipping elements cross the point of no return, they have the potential to completely alter the face of the Earth. So, how will this affect us humans? So far, only icebreakers have been able to travel the Arctic Ocean, and only in specific places and during specific months of the year. Obviously, remove the ice and the ocean becomes navigable, even for less equipped commercial ships. On the one hand, this could be beneficial. Shipping routes will be cut in half, decreasing emissions by the same amount. However, this poses extra hazards to the ecosystems there. Oil leaks, accidents, and adrift containers may become more common in an environment where cleanup and rescue will remain difficult. Another result will be a shift in geopolitical balances, particularly in light of recent events. This might be disastrous for the environment. In certain places, the Arctic Ocean is more than 5 kilometers deep. Remove the ice and it will have significantly lower albedo. The more sunshine it absorbs, the warmer it becomes. This might have a cascading effect on the neighboring areas. First and foremost, North America, Europe, and Asia will lose one of its primary weather stabilizers, resulting in more extreme weather events. Remember wildfires, summer heat domes, and cold snaps in the winter? So, brace yourselves for more. And, of course, the second effect will be greater ice melting. Although the speed will most likely be determined by our emissions. More fresh water will enter the ocean as ice melts. This could be enough to tip the ocean currents and disrupt the plankton CO2 sinks. Not to mention sea level rise, which Greenland alone would contribute an additional 7 meters to. Even if full melting could take millennia, we could observe the first effects within the next several decades. However, the most significant impact of Arctic Ocean warming could be tied to the tipping point I saved for last. Permafrost, or frozen soil, surrounds the Arctic Ocean in Canada, Europe, and Russia. It has already begun to melt, forming lakes and crumbling under its own weight. The issue is that as it melts, it releases carbon that has been trapped for millennia. According to the experts, melting permafrost will release twice as much carbon into the atmosphere as it presently does. This includes not only CO2, but also methane, which has a 30 times greater greenhouse effect. Time is running out, but there is still hope. So to answer the remaining concerns, why would the melting of Arctic ice indicate that we are losing the climate battle? Because the next step could be melting permafrost and a temperature runaway. What do you think, guys? Is there anything you'd like to say? Let us know in the comments and don't forget to subscribe.